Our next speaker is Anli. No, are both Melissa Elkadi and Anli from EpiSci, and they will talk about 5G SL synchronization signal block simulation. Sorry. So.
Okay. Hi. It's good, the mic. All right. My name is Melissa Elkadi. I am not on, and I wish I was on, not up here, but that's okay. So I'm going to talk to you guys today about our SideLink demo. So we're just getting started with SideLink, and we're building a 5G SideLink Mode 2 demo. Specifically, we're focusing on UE to UE with no G, no G, which is Mode 2. And for now, we're focused on the broadcast channel and transmitting the SSB, which is the SideLink synchronization signal block, and then receiving it in the receive UE. So we created a PSBCH simulator, which is very similar to the PBCH OAI simulator that already exists. It's for the SideLink broadcast channel. We are conducting a simulation and test for various channel conditions. We set up the UE5, we generate the SSB frame, which includes the PSBCH, the DMRS, the PSS, and the SSS. So as you can see in the block diagram here, the focus of the demo is going to be strictly in the PHY layer, specifically the broadcast channel. So here is a quick setup of how our simulation works. So the blue UE on the left is going to be the sync-ref UE. What it's going to do is it's going to create the synchronization signal block, the SSB. It's made up of the PBCH first, and then the PSS symbols, the SSS symbols, and then the remaining PSBCH symbols. These will get broadcasted out, and any nearby UEs will pick this up. They will decode it, and they will use this as a reference timing to be able to connect to the sync-ref UE. So this is one of the first steps in 5G SideLink development because it goes through the synchronization process, and it actually carries all of the synchronization information. So this here is just a quick block diagram of the steps that we took to achieve this simulation. So first we focused on the simulator. We created an executable in OAI. We created the user interface, the channel estimation. We initialized all the UE parameters, the 5 parameters. Then we generated the PSBCH gold sequence, the PSS, the SSS, the DMRS symbols, which are every 4th symbol of the PSBCH, full payload. We put the whole thing together for the SSB frame, and we transmit it. Well, we apply channel conditions, and then we transmit it. The receive UE will then pick it up. It will conduct the channel estimation. It'll demodulate, unscramble, decode, and then finally we'll report out any errors, CRC errors, or payload errors. So here's a quick slide for future work. This future work, basically what we're doing now is the stepping stone for the remaining 5G SideLink. So our future work is to conduct over-the-air testing for the broadcast channel. After we conduct that over-the-air testing, we would like to complete the full 5G SideLink implementation, possibly partner or work with Eurocom. For now, we're focused on Mode 2, which again is without a base station or a G node B, but in the future, we could move towards Mode 1. I don't think we have time for questions, but we'll happily take them at the booth. And we might ask you guys questions there too. And then here's our lab setup that we have at EpiSci. We'll use this for over-the-air testing, and we have some of the equipment with us if you guys want to see it. So thank you, everyone, for having us. And we're not complete. Oh, I shouldn't be the one to do it as well here. Okay, so EpiSci is a small business. We're actually located here in San Diego. We primarily focus on like drones and AI machine learning, but we do have a 5G team here. There's An and David and Nijaz, and we worked closely with OAI for a previous project, which I will be up here presenting about tomorrow. And then we're starting to get our feet wet with SideLink, and I hope that's good enough.